The Game of Algorithms. A Tale of Deep Learning in the Kingdom of Intelligença. Part 1. The Kingdom of Intelligença and the King Neuron. In the vast digital realm of Intelligença, where ones and zeros danced in the rhythm of algorithms, reigned the wise and beloved King Neuron. This kingdom was not of soil and stone, but of data, numbers, and infinite possibilities. King Neuron was known for his wisdom to make decisions based on the complex inputs he received from his vast kingdom. His castle, lair, was an intricate web of halls and corridors, each a conduit for the information that flowed through, getting transformed along the way. Layer was not a singular entity but a part of a larger system, interconnected with other layers, forming the mighty layered network. Part 2. The activation function and the princesses Rilu and Sigmoid. The king had two daughters, the princesses Rilu and Sigmoid. They were known as activation functions. Princess Rilu, the older of the two, was straightforward and fierce, embodying the spirit of, if it's less than zero, neglect it, or keep it otherwise. On the other hand, Princess Sigmoid was more intricate and delicate, always ensuring the balance by keeping the values between 0 and 1. Part 3. The Royal Advisor, Gradient Descent. The king's trusted advisor, Gradient Descent, was an old sage who had a unique ability to learn from mistakes. He was continually refining, always looking for the path of least resistance or error, leading the king and his court to better, more accurate decisions. Part 4. The enemy, loss function. The peaceful realm of Intelligença was not without its threats. The kingdom's greatest enemy was loss function, a cunning sorcerer who would reveal the difference between the predictions made by King Neuron and his court and the ground truth. The battle between the king and loss function was a continuous one. Every prediction, every decision made by the king and his court, loss function would challenge, revealing the gap between what is and what should be. Part 5. The heroic technique, backpropagation. In this never-ending battle, a hero emerged, known as backpropagation. A skilled warrior, backpropagation, had the unique ability to distribute responsibility. He could trace back through the layered network, attributing a portion of the loss function's power to each part of the kingdom, helping Gradient Descent understand where and how to adjust to improve the predictions. Part 6. The quest for knowledge, training and learning. Thus, the quest for knowledge was an ever-cycling journey, a continuous process of predicting, comparing with the ground truth, adjusting based on the error, and predicting again. The kingdom was continuously learning and growing, becoming more accurate, and reducing the power of loss function. Over time, the Kingdom of Intelligença, under the rule of King Neuron, using the power of princesses Rilu and Sigmoid, the wisdom of Gradient Descent, and the bravery of backpropagation, flourished and evolved. The kingdom became an embodiment of a deep learning system, navigating through the realm of data and knowledge, creating a better understanding of the infinite world of information. This story incorporates deep learning concepts into a fantasy narrative. King Neuron represents the neurons in a neural network that process inputs. The layer is the castle where the neurons reside, and together they form the layered network or deep neural network. The princesses, Rilu and Sigmoid, are activation functions that decide whether and how much a neuron should fire. Gradient Descent, the advisor, stands for an optimization algorithm that minimizes the error or loss. Loss function is the measure of error in the network's predictions. Lastly, backpropagation is the technique used to distribute the error back through the network, guiding how much each neuron's weights should be adjusted to improve the predictions. The process of continuously making predictions, measuring the error, and adjusting based on that error is what constitutes the training and learning process in a deep learning system.